This is an introduction to the Forest Manufacturing Model 308 grinder router. This machine is specifically part of our line of insulation fabrication equipment. So if you are fabricating, well, specifically this machine is used for preparing material to cut into pipe covering. If you don't know what pipe covering for insulation is, I'm going to have to ask you to step back and do a little more research or call us. But this is meant specifically for the insulation industry. This is used as the first step in preparing product to be cut into pipe covering on the Model 103 or Model 106 as a pipe covering machine. So when I say grinder router, what we are doing here is we are working with a block of material, usually something like cellular glass, sometimes calcium silicate or polyisocyanated other materials, and we are preparing them by cutting the inner diameter of insulation, sized to match a mandrel on the Model 103 or 106. To do that, first we have three variables. The first is the size of the cut you are making. To determine that, we have a range of grinding wheels. They're all 8-inch diameter. The largest we can work with is 3.5 inch. The smallest is 5/8. These mount in the machine, and this determines the profile that will be cut or routed in the material. Mounting the routing stones. First, you have to lift up this table. Oop, safeties. Under here, we have what we call the mounting arbor for routing the stones. I've already got one mounted here. So the arbor here is about 5 inches long. Obviously, as I just showed you, some of the stones will be as little as 5/8. This is a 1.315 stone, matches up to 1-inch pipe. To mount this on the arbor, first mount this on, then we have this washer, spacer, and nut. The idea here is slide the grinding wheel onto the arbor. Then there's a fixed washer on the arbor. So you want to sandwich the grinding wheel between the fixed arbor and between the fixed washer and this floating washer. And now I've got like 3.5 or 4 inches of exposed thread here. So I can, in theory, just run the nut all the way down. What I prefer to do, just make life easier, we provide a couple of spacers like this. Slide it on over the arbor thread. Then you can screw on your nut. You're not having to run the nut down 4 or 5 inches. This arbor shaft is driven by a motor. The motor has an integrated brake such that when I stop the motor, it stops just about instantly. That also means that when the motor's not powered up, I can't spin the shaft. So I do not need to counterhold the shaft to tighten this nut. I can just put my grinding wheel on, my washer on, one of the sleeves if necessary, and then tighten my nut. You don't have to get really on it, just snug it up a bit. And I don't have to counterhold the shaft because it's being braked by the brake motor. So that's the first variable. What size, radius, full round am I cutting here? Next variable is how much this projects above the table surface. So I'm going to be running a block of material, mounting on the table, pushing it into the spinning workpiece to make my cut. So I need to set how high this grinding wheel projects above the table surface to equal 1/2 of the radius. To do that, you can see it over here, I've got 2 jacking screws. 2 instead of 1, because we used to use 1 right here in the middle. That led to the whole thing being a little wobbly. With 2 screws, you're on 4-point contact, it just feels more solid. So to set the height, I recommend using something like a little machinist square. Set it to the height you need. In this case, I know I need just a smidge over 11/16. Set that here, and then I can adjust these screws. They have lock nuts, by the way. Back up the lock nuts really generously. So I can adjust these screws up or down as needed to set that height. Get them both engaged so it doesn't rock. You can usually just hand tighten these screws. You don't need to really, again, you don't need to really get on them. There's not much trying to move them. So that takes care of the height. Make sure I have a full round. As you can imagine, if I have this projector too tall, I'll be cutting out a tall, skinny piece out of my material. Or if it's too short, I'll just be taking a little sliver out. So, setting the height, Acme screws. The next piece of the puzzle is setting where on the material I want to make the cut. So I have my material. Actually, quick note here, while I'm setting this up, I want to make sure I'm going the right direction. There's a motor starter on the back side. Hit the motor starter, the wheel is turning this way. I want to feed the workpiece into the wheel. So I'll be working from this side, pushing in. To adjust this fence position here, well, the fence position tells me push the workpiece up against the fence, then I can slide the workpiece in. This fence position dictates where on the grinding rock I'm going to make my cut. This material, by the way, is cellular glass. It's not dangerous, it's basically glass, but it's very rough. If you touch it too much with bare hands, you're going to wind up just taking the fingerprints off your hand. So to adjust the position of this, we've got these 2 locking pucks. Unlock this, 1 full turn's plenty. And then over here we have a hand wheel. Turn the hand wheel, and we can adjust the position of the fence. Lock it back down. This will move. Definitely want to lock these down. Again, you don't have to get on it, just snug it up. You don't want this moving while you're making cuts, or your cuts be in different positions. And another important step. As you might imagine, grinding a material like this makes a lot of dust. We have a dust collection funnel below the grinding rock here. We have hooked up a dust collection system to it. I'm going to walk off screen temporarily, turn the dust collection system on, such that while I cut this stuff, the dust gets sucked up. All right, that's a lot of talking. Let's do some cutting. Turn the motor on. Gently push the workpiece so that it stays against the fence. And that's what it does. Carved out a clean half round. I'll do it again on the, flip the workpiece 180 degrees, make a second cut. Turn the motor off. You notice it stops pretty much instantly. Now I have two cuts on this workpiece. These are sized to match a 1-inch mandrel, 1-inch vacuum mandrel on a model 103. So I'll get two insulation half rounds out of this block. All right, some other notes here. Why grinding rocks? Where did I put those down? Here we go. I have customers ask me, why am I using a grinding rock? Couldn't I work faster if I use something like had paddle wheels? Safety. So this grinding rock, we're spinning it pretty fast. I think the speed's 2,500, 3,000 RPM, something like that, pretty quick. You don't want to touch it, obviously. If you touch it with gloves, well, it's going to be annoying. If you touch it with your bare fingers, you're going to get a burn, but it's not just going to immediately take your finger off. If you have a paddle wheel, and we actually explored this once, if you have a paddle wheel, instead of just having a continuous grinding surface, you have basically blades here, here, here. Those blades, it's very easy to get your finger in between the paddle wheels, and now instead of just burning off your fingertip, you're taking off 1 or 2 joints worth of finger. So the paddle wheels are simply frightening. This, it'll certainly burn you. It might take off some skin where you touch it with bare skin while it was running, but it's not going to take off fingers 1 or 2 joints worth. Paddle wheels would. This is the safer option. Other notes about handling. These are very hard, resin bonded, it's a very coarse grit. I once asked we have these custom made for us, and I once asked the manufacturer if they could make it coarser, and they said this is the biggest grit available. In the world of grinding media, these are boulders, so we cannot get these any coarser. They do cut pretty quickly, as you saw. My limiting factor on cutting just now was this table is currently painted, so I'm sliding something that's the next best thing to sandpaper across the painted surface. It's sticky. What'll happen is, in use, you're going to take the paint off, you're going to polish up the steel table, stuff will glide across much more easily. But I have to paint these before I send them out. These are hard, but they are also brittle. Do not drop these. They may just break, fall apart. It's also possible if you drop these, you get some kind of internal cracking. It may look like it's intact, but it's got internal damage. If you put a damaged wheel up here and spin it up to 3,000 some odd RPM, there's a chance it'll fly apart. I've never heard of this happening. It may never have happened. Maybe my customer all just very careful, but as a good rule, if you drop this grinding stone, throw it away. Don't try to use it in the machine. And that is the Model 308 grinder router. If you have any questions or would like to discuss a specific application, please feel free to call or email us here at Forrest Manufacturing. Thank you for your time.